Today we are going to speak about biomechanics in sports and exercise science, Unit 7. In the domains of sports and fitness, levers and axes of rotation are crucial for achieving maximum effectiveness and efficiency. The many applications of lever types and axes of rotation are explained as follows. In sports, like sprinting and leaping, where the resistance is situated between the applied force and the center of gravity, Class 2 levers are frequently observed. For example, during a sprint, the leg muscles contract to provide the applied force, the foot serves as the fulcrum, and the body's weight acts as resistance. In games like basketball and volleyball, the ankle joint acts as the pivot, while the power of leg muscles and gravity acts as resistance. Class 3 levers are commonly used in sports methods that demand dexterity and control, since the effort is placed between the resistance and the fulcrum. In sports like badminton and tennis, the arm acts as the lever, the hand exerts the effort, and the racket provides the resistance. By modifying the lever arm, athletes may accurately apply force to control the ball's direction and speed. Joint axes of rotation play a crucial role in weight training exercises like squats and overhead presses. For example, in a squat, the hip and knee joints serve as the axis of rotation, facilitating the intentional movement and muscle activation. Exercise machines often incorporate lever systems to provide resistance and facilitate certain exercises. In a certain extension machine, for instance, the lever arm, fulcrum, and resistance cooperate to effectively target certain muscle groups. Two examples of machinery that makes use of Class 1 levers are rowing machines and chest press machines. Through the application of force against resistance, these devices improve overall physical fitness and muscle activation. Levers and axes of rotation are concepts that athletes and fitness enthusiasts need to understand in order to optimize performance, prevent injury, and accomplish their training goals. Performance in sport and exercise is undoubtedly impacted by change in the center of mass, stability, and equilibrium. The body center of mass is the location at which all of its mass is concentrated. Stability and balance are improved when the center of mass is positioned and kept in the correct position. This is important for exercises like yoga, martial arts, and gymnastics, where athletes need to maintain a steady center of mass to execute intricate motions with control and accuracy. Agility and maneuverability. Athletes can enhance their agility and maneuverability by deliberately shifting the location of the center of mass. Players in sports like basketball or soccer frequently adjust the center of mass in order to change direction quickly, dodge opponents, or execute quick turns or crossovers. Power and force generation. In exercises like weightlifting, throwing, and jumping, the center of mass contributes to the production of power and force. Athletes can transfer force more effectively and produce their maximal power during movements when the center of mass is properly aligned, which improves performance. Stability in flight. Athletes must regulate the center of mass to be stable during aerial maneuvers. In sports like diving, gymnastics, or skiing, they can improve their control and carry out intricate maneuvers while in the air by modifying their center of mass and body position. In hockey, the principles of lever and axis of rotation are crucial for performing a wide range of moves on the ice. Levers are simple mechanisms that spin a rigid bar or beam around a fixed point. Axes of rotation are the locations around which objects rotate or pivot. Understanding these concepts in the context of hockey aids in elucidating the biomechanics underlying the movements of the sport. The finest quality levers have a pivot point that links the resistance and the force of effort. In hockey, hitting the puck is a well-known illustration of a first-class lever. The player's hands serve as the fulcrum, the bail as a resistance, and the stick as the lever. In order to propel the ball with force and accuracy, players swing the stick with their hands while applying force. On second-class levers, the weight is positioned halfway between the fulcrum and effort. Second-class lever notions are less common in hockey, although they are nevertheless noticeable in certain defensive plays, such as stick blocking or stopping the ball. In this case, the player controls the course of the ball by exerting force through the length of the stick. The hand gripping the stick serves as a pivot. The resistance comes from the approaching ball. Third-class levers distribute the effort between the weight and the fulcrum. In hockey, dribbling the puck is an excellent illustration of a third-class lever. The hand grasping the stick serves as the fulcrum. The ball provides resistance and the player's arm muscles apply force. Players can maintain firm control over the ball as they move across the pitch by using their stick skills to properly direct the ball. Axes of rotation are crucial for maneuvers in hockey such as pivoting, turning, and dodging opponents. Understanding these biomechanical principles can help players perform better on the field, whether they are passing, shooting, defending, or controlling and maneuvering. The center of mass has a considerable impact on a hockey player's balance, ability, and overall performance. Shifts in the center of mass, or the point at which an object's mass is concentrated or balanced, can have a significant impact on a player's ability to move swiftly, exert force, and maintain control of their movements. When the center of mass moves, stability and equilibrium suffer. Accurate shooting, passing, and dribbling are just a few of the hockey skills that need balance. When a player's center of mass is low and focused on their base of support, they are more stable and capable of resisting outer stresses such as tackles and opponent challenges without losing control. On the other side, if a player's center of mass is excessively high or incorrectly positioned, the performance on the field may suffer, leaving them more prone to losing their balance and falling. A shift in the center of mass impacts stability and balance. Maintaining balance is essential for hockey skills, including effective shooting, passing, and dribbling. When a player's center of mass is low and centered on the base of support, they are more stable and capable of absorbing external pressures such as tackles and opponent challenges without losing control. However, if a player's center of mass is too high or wrongly positioned, they risk losing their balance and falling, which may impair their effectiveness on the field. Furthermore, in hockey, the center of mass affects power generation and transmission. To increase power and accuracy, players align their center of mass with the intended direction of the shot while striking the ball for a pass or shot. By properly positioning their body and synchronizing the movement of the center of mass with the swing of the stick, players may generate more force and velocity, resulting in more potent shots and passes. To summarize, changes in the center of mass have a substantial impact on hockey play, impacting power production, balance, stability, and agility. Learning and understanding center of mass biomechanics allows players to maximize their motions on the field and improve their overall performance in the game. A variety of lever types and center of mass changes are required to enhance hockey performance on the pitch. Simple machines like levers are required for dribbling, passing, and shooting, and changes in the center of mass affect power generation, balance, stability, and agility. Learning about the interplay between these components can help you better grasp the biomechanics of hockey performance. First-class levers are typically seen in motions like hitting the ball or making defensive maneuvers. When the player strikes the ball with the stick, his hand acts as a fulcrum and the stick as a lever. Players can make accurate passes or strong strokes by placing their hands correctly and using the length of the stick. Changes in the center of mass are necessary to maintain stability and balance during these motions. To increase control and accuracy, players move the center of mass to align with the intended direction of the shot. Although they are uncommon in hockey, second-class levers can be seen when playing defense and stopping or intercepting the ball. In these instances, the player's hand serves as a fulcrum, the stick as a lever, and the force of the oncoming ball serves as resistance. Players may intercept the ball with more power and control if they use the whole length of the stick and position their bodies correctly. Third-class levers are commonly utilized for ball dribbling and maneuvering. When dribbling, the player's arm muscles exert effort to control the ball's movement, with the hand holding the stick, serving as a fulcrum. Changes in sense of mass during dribbling are critical for maintaining balance and agility. Players can go past opponents quickly and precisely by dynamically shifting their weight to adjust to changes in direction. In hockey, the combination of different lever types and sense of mass changes is critical for top performance. Athletes who understand and master these biomechanical ideas can improve their abilities, enhance their precision and control, and finally thrive on the field.